Assalamualaikum and hello to Sir Tuan Yusof and all my friends. My name is Muhammad Azrul Hanif bin Himi and I'm second year mechanical engineering student from University Technology Petronas. In this video, I'm going to present a lab report about Bernoulli's experiment, and this video is for fluid mechanics subject under the code MEB2043. So basically, I will go through the introduction of the experiment, objective, apparatus, procedure, experimental result, and discussion before concluding my lab report presentation. So moving on to introduction of the experiment, according to Bernoulli's principle, when area available for the fluid to flow decrease, then the fluid velocity will increase, and at the same time, the fluid pressure or the fluid potential energy will decrease. And this principle was named after the Daniel Bernoulli, who first wrote this principle in a book named Hydrodynamics. And some application of the Bernoulli principle can be seen from air flight, lift, baseball, draft, and sailing. Plus, Bernoulli's principle stated that in a steady flowing fluid, the sum of all the mechanical energies, which include kinetic energy, dynamic head, fluid pressure, and potential energy, should remain same at all the point of the flow. So, Bernoulli equation can be written in many forms, as you can see from the slide. So basically, Bernoulli equation consists of flow energy, which of pressure head, kinetic energy or velocity head, and potential energy or elevation head. But for horizontal pipe, when the inlet and outlet are at the same height, the z quantity, which represents the height, can be removed to give a new form of Bernoulli's equation, which you can see from the slide. And this equation can be used to calculate the height of any point of the flow. Next, moving on to the objective of the experiment, the first is to use the venture-meter apparatus to study the effect of area of the flow velocity and fluid pressure. Second is to use the Bernoulli's equation to compare the behavior of ideal and real fluid. This experiment basically required three apparatus, which is venture-meter, supply hoses, and measuring tank. But how the experiment was conducted? First, we place the venture-meter onto a horizontal surface and note the height of input valve and output valve and make sure they are same. Then, we attach the apparatus with the power supply but keep the supply off. Next, we open all the air bleed valve of the manometer present at the top. After that, on the power supply to run the pump and adjust the flow rate control valve until water level in all the manometers is at readable range. Next, place a stop plug in the basin and take note the time required to fill the basin with specific amount of water. After that, remove the stop plug to drain out all the water. Then place the dynamic pressure probe with the static pressure port and measure the manometer data from both of the probes. Then, place the dynamic pressure probe with the next static pressure probe and measure the manometer data from the probe. And these steps are repeated for measuring data from all the manometer probes. And finally, turn off the pump and set off the power supply. So here is roughly what the experiment looks like. Next, moving on to the result. So here is the sample calculation. First, we calculate the flow rate and we use the value of the flow rate to calculate the velocity of the flowing fluid. After that, we use the value of the flowing fluid to calculate the height at the point 2. So here is the tabulation of data obtained from the experiment. As we can see, the experiment was repeated at least 3 times to avoid any error and to get average result. For each test, different positions are calculated to find the experimental value of the height and also the theoretical value of the height. And these two values are compared. So here is the graph of theoretical values and experimental value of the height plotted for each test. As you can see, there is a little amount of error between the experimental value and the theoretical value for each test. So moving on to discussion, from the tabulation of data and the graph, it is very clear that with the decrease in area of the flow, the velocity will increase and the pressure will decrease. And as shown in the graph of all the 3 tests, that the decrease in area of the flow decrease the water height in manometer column, and this means that they are directly proportional to each other. Next, we can conclude that the water is not an ideal fluid because there is a difference in the theoretical and experimental value of the height. And the most important thing is the height of water in the final column was not equal to the initial values. We show that there are friction losses in water particles. And this type of information is very useful in the case of nozzles, jets, and diffusers. So as the conclusion, the aim or the objective of the experiment was to discuss the behavior of ideal and real fluid and on the basis of the test result, it can be concluded that the experiment was successful because there is difference in measured and theoretical values of the height. And this difference is due to the friction losses in the real fluid, because the ideal fluid does not have friction losses. And from this experiment, it can be concluded that with decrease in area of flow, there is an increase in velocity and decrease in the flow pressure of the fluid. So that's all from me. Thank you.